Hello, I hope that you've had a great time with the exercises and the challenges of lesson 5. For lesson 6, we're going to take a little break from proving, so I hope that you'd also welcome that slight change. Lesson 6 is going to be a preparation for truth tables, and so our task for lesson 6 will be to determine what makes a statement true or false depending on the status of their elements or their ingredients. So welcome to lesson 6. So the key idea for the truth table can help you figure out if a statement is true or false based on the truth or falsity of its elements. Or in other words, what is it that will make, say, a conjunction true or a disjunction true or false for that matter, or what is it that would make an implication true or false? So let's take them one by one. Let's begin with, I guess, the simplest, single letters. We already know that P is the opposite of not P. So just to give an example, like in a game of football, okay, either the ball is in or the ball was out. So if it's true that it is counted, then it is false that it is not counted. On the other hand, you can also say when it is false that it is counted, then it must be true that it is not counted. It's really just, one or the other. Is that a point? Is that a score? Is it counted or not? If it's true that it's counted, then it's false that it is not, and vice versa. Express this now in a truth table. Thus, you recognize, well, P only has two possibilities. Either P is true or false. And from the example, perhaps you have already seen that if P is true, not P will have to be false. And if P is false, then not P will have to be true. Okay, that would be the relationship between P and not P. If P is true, not P must be false. But if not P is true, then P has to be false. Simple enough. Let's move on. What about conjunctions? Let's jump immediately to the example. Thus, in this example, perhaps you might imagine, so father and son must each have a guitar for the lesson to be fruitful. And so for us to be able to follow the recommendation here, okay, the father has to have a guitar and the son has to have a guitar. The father has a guitar and the son has a guitar. In other words, what I'm trying to say here is that when we are talking about conjunctions, for us to be able to follow a recommendation like this one, then both elements will have to be true. Let's express this then in a truth table. So here are the basic letters, right? P, Q, and we shall inquire into the status of the conjunction of these letters, P and Q. This time, there will be four possibilities or four combinations. One combination would be P is true and Q is true. Another combination is P is true while Q is false. And then false for P, true for Q. Lastly, false for P and also false for Q. Going back to that recommendation, we now ask, given what we have on the left, what would be the status of the conjunction P and Q? If P is true and Q is true, that keeps the conjunction true. Does the father have a guitar? Yes. Does the son have a guitar? Yes. Does that lead to a fruitful lesson? Definitely. If P is true while Q is false, we're now on the second line, we discover that the conjunction becomes false because one of the elements is false. I guess you'll also say that's true as well for the third line. What if you switch around and say, well, P is false while Q is true? You'll end up saying that the conjunction is false. And lastly, if both elements are false, you would judge that the conjunction will also be false, coming from the simple principle that for a conjunction to be true, all of the elements need to be true. So long as one element of the conjunction is false, that automatically makes the conjunction false. And of course, if all of the elements of the conjunction are false, then the entire conjunction becomes false. Moving on, what about disjunctions? Let's paint ourselves a scenario here. Let's say you're playing basketball, an official game of basketball. The score is tied, and before regulation time ends, your attempt to shoot is fouled and the ball didn't go in. If you know more about football rather than basketball, this is similar to the penalty kick at the end of the regulation game. And so, in basketball, in a situation like this, you will be given two free throw shots. So, what do you need to do to win the game? You may express this then as a disjunction. Either I convert the first throw or convert the second throw so as to be able to win the game. Each throw, by the way, will give you 1 point. And since the game is tied, all you need is 1 point to be able to win the game. So the disjunction goes, if my objective, of course, is to win the game, either I convert the first throw or convert the second throw. Let's express that in a truth table. Okay, so there's your P or Q. P would be the first throw, Q would be the second throw. Again, there are 4 combinations. If I convert the first throw and the second one, do I make the disjunction true? Of course. In the end, I still win the game. Okay, I guess we'll say with a 2 point lead. What if I convert the first throw, but I fail on the second throw? I make the P true and the Q false. P or Q still remains true. Because again, the objective is to be able to just sink or convert one free throw. Same is true for the third line. It's okay if the first free throw doesn't go in, so long as I convert the second free throw. And so if P is false and Q is true, P or Q still remains true. That's the only way, I guess, for the disjunction to be false is if both of its elements are false. If I don't sink the first throw and I also do not sink the second throw, both are false. I end up losing the game, or well, keeping the game, I guess, tied, and the game goes into overtime. But the point is, I'm not able to achieve the objective of winning the game at that point. Thus, for disjunction, all you really need is for one element of the disjunction to be true for the entire disjunction to be true. And if you say, what if both are true? Well, that would be better, right? Not really required, but that would be better. Because all you need is one element of the disjunction to be true for the entire disjunction to be true. Now we get to the more complicated one. Let's talk about implications. So let's use this as an example. Okay, think about this implication. If an effective vaccine to eradicate COVID-19 is discovered, we can return to the classroom. And so the implication assumes some sort of logical connection, maybe even a necessary connection between the discovery of an effective vaccine and our chance to return to on-site classes. So A here would be the discovery of an effective vaccine, and B would be our chance to return to the classroom. Let's put that then in a truth table. So let's go back to P and Q. Okay, let's return to using P and Q, where P is an effective vaccine to COVID-19 is discovered, and Q would be we find ourselves in the classroom. And so we inquire, what would the status of P implies Q be? Again, there are, of course, four possibilities, right? If it's true that an effective vaccine is discovered, and it's also true that we find ourselves in the classroom, you can now judge P implies Q as true. True antecedent, true consequent, true implication. In the next case, if P is true while Q is false, so if the vaccine is discovered but we don't find ourselves inside the classroom, you will judge the implication as false because the consequent or the effect didn't really follow from the antecedent or the cause. Okay, I guess it's all clear up to this point. But what if the antecedent or the cause itself is false? What if, the effective vaccine is not discovered, but we find ourselves in the classroom? Maybe again, for some other reason, what if the vaccine just simply dies out? Sorry, not the vaccine, but what if the virus simply dies out, because that happens in epidemics and pandemics where the virus simply just weakens and stops wreaking havoc. Then you can't really tell, right? We weren't able to test the theory. We were not able to verify because the vaccine is not discovered. That leaves you a question mark. And what if, like perhaps at this point we'll say this is the status quo. This is what how we find ourselves now, that there is no effective vaccine yet, and we're not yet in the classroom. So both P, Q are false. Leaves us still to um, say maybe, right? Maybe the implication is true. We can't really tell. Now, how do we decide then for this one? The truth table has to work one way or another. We shall allow ourselves the provisional judgment that when the antecedent of the implication is false, we assume that the implication is true. And I guess you can say even that this is scientifically sound because scientists also, I guess, adopt this idea that so long as a theory has not been invalidated, proven false, then let us assume then that the theory is true or at least possible. Okay, so we've completed all of the necessary details to be able to make a judgment if a conjunction or a disjunction or an implication is true or false. You can review some of these slides in lesson 6. So I ask you to go over those slides, and then good luck with the exercises, and I hope that you'll have fun with those exercises. Thank you for listening.